All right, guys, welcome back to another KevCAM night class tonight. Tonight I have Andrew helping out with questions that pop up along the way. Andrew, are you with us?
I'm here. Thanks, guys.
All right, guys, so thanks again for attending the night class again. And for those of you guys that are new, I do see one new name in there. These classes are solely dedicated just for you guys as a training, learning, after hours free training for you guys. So we do offer a send your idea over to me and we'll send you some SolidCAM swag as a thank you. So we have gotten quite a few suggestions from you guys, which has helped out a ton on what to teach. And for those of you guys that don't have my email address, I will put it into the chat for you guys. And for those of you guys that are new also, we are using GoToWebinar, and this puts everybody in mute just to eliminate any background noise. But if you guys do have a question, which definitely hope you guys do, put it into the chat section of the GoToWebinar, and Andrew will ping me and read off the question, and we'll get your questions answered right away for you guys. Totally laid back, off the cuff here, so we're not following an exact schedule, so definitely feel free to ask those questions. And then one other thing I want to let you guys know about is the YouTube channel. So all of our night classes are recorded. We do have a SolidCAM University channel, and I will put the link for that also in the chat for you guys. And right here, like I said, we have tons of tips and tricks video and the full night class videos in here. Trying to add content in here a couple times during the week, but short tips and tricks videos to full hour-long classes, live cuts and all that good stuff. So come here, check it out, and hit the subscribe button so you guys can get notified when we add new stuff in there for you guys. But other than that, we will get the ball rolling tonight with the contour 5-axis milling. Okay, so with contour 5-axis milling, you know, I know 2 weeks ago we were talking with Tim Micah, and you guys can get a less expensive simultaneous 5-axis toolpath. And when you get that toolpath, you get the contour 5-axis machining, you get the multi-axis drilling, and you get the swarf machining. So that's what we're going to be kind of covering tonight. Is we've covered the swarf, we've covered the multi-axis drilling. So now tonight we're going to do the contour 5-axis. Now this is kind of geared towards trimming, 5-axis trimming for you guys. Also kind of geared towards when you guys actually don't have a surface to select for doing a 5-axis operation. It's all based off of the trying to think here. I got to open up the operation. It's all based off of the orientation lines. Sorry about that. And with these orientation lines is we're basically kind of telling it what direction we want that tool to be pointed to. So you'll notice that when we're doing a contour 5-axis, we're not actually selecting a surface like we have been with simultaneous 5-axis or swarf. We're actually selecting just a drive curve versus a drive surface. So like I said, this works real good with the trimming feature if you guys are doing a 5-axis trimming, or if you guys are trying to work on a 5-axis contour and don't have the full-blown simultaneous 5-axis. You guys get a lot of control off of these orientation lines, and I'm going to go through a couple examples for you guys to kind of show you. But it's a really great toolpath in here. Added a lot of stuff in there for you guys. So, okay. So we'll get the ball rolling here. So for geometry, basically what area what curve do we want to base it off of? So for this particular one, we can get our drive curve and do our constancy propagation here. And it's going to wrap that chain all the way around for us. Excuse me. So now I'm telling it to follow this curve with basically the edge of the end mill, or I can do center of the end mill, or left side, right side, all that good stuff. Now, basically, how do I want that end mill to be orientated? So we have what's called our orientation lines here. So if we can go ahead and click this, and for this one, I actually added a couple additional lines in here. You guys can draw as many as you want in here. This is basically going to control your tool on how it's kind of going around a part here. So for this one, we can grab this line, and unfortunately I made that surface red, so it's a little tough to see the arrow, but in this particular case, I want my arrows pointing up. The arrow direction does matter when you guys are doing these lines. So keep that in mind. Oh, I keep forgetting to hit the checkbox. And grab these lines going around here. Like I said, the more lines we have in here, the better axis control you guys will have. All right, almost got them picked here. The dead silence is always scary, isn't it? All right, almost done here. Okay, got all our lines picked, making sure all our arrows are going all in the proper direction, pointing up for this particular cut here. So we can go ahead and say okay to that. You notice, like I said that before, didn't pick any drive surfaces or any surfaces at all, so you don't need any surfacing features to pick here to do the contour. It's all based off of the drive curve and the orientation lines. So now we have down here, which is a snap distance. What is the max distance between each orientation line? So for this one, I can just put, ½ inch in there, and should be more than enough to cover all those. If you put that number larger, if we do like 1 inch, we may skip this one snap line right here. So, okay, so let's grab a tool. And we'll just grab this tool too. One thing I forgot to do is kind of like our 5-axis that we've been covering and the HSS, we do have the ability to do a 2D boundary. If you wanted to keep a toolpath just on a particular area and not have it go outside that boundary area, we can definitely set up a boundary like we have with all the other operations. Levels, really not going to mess with here since we're kind of working on more or less a flat plane right here, kind of going around. Now, toolpath parameters. In here is kind of, you guys are used to seeing this with the 5-axis. We have our cut tolerance, so we can crank that up or leave it as loose as you want. We have our sorting. Now, you guys are used to seeing spiral, one way, and zigzag up here. Just going to go the one way as you picked your chain with your chain direction. We can do follow curve chain, which is default. We can do counterclockwise or clockwise. So definitely pick your direction, which way you want to go there. You guys can actually pick a start point if you guys want to change it up so it's starting in the center or in a specific area. Definitely use that start point right there. And then cutting side, we have our standard left, right, center, inside, and outside of that geometry that we picked for our drive curve right here. So with this pretty basic standard, if we go to modify, we can do an extend, trim, and also doing the round corners here. Now, tool axis control is going to look a little bit more familiar for you guys right here. So we got our, we can do tilted to relative cutting condition, tilt through points, tilt through curve, tilted from away from curve, and tilted from curve away. So you got a couple different options there. I'm not going to go into too much details of what these kind of do right here, since we already covered that in the simultaneous 5-axis portion. But we can put an angle on there if we want to be tilted to it. But we'll just leave it tilted relative cutting condition. And then I want to follow the ISO line direction. And we do have an advanced, so we can do our fanning lead and leg kind of right here also. We can also set up our angle range. So if we just want to keep that cutter to stay within a certain angle range limit, we still have the same option like we did in simultaneous 5-axis. Linking is going to be the same that you guys have been used to seeing. If you guys have links that we need to clean up or anything like that, we can switch these over. The rest of this is pretty much the same as the HSS and 5-axis. The only thing right here is when we do a gouge check, there's no drive surface. You'll see we don't have a drive surface over here because we didn't actually pick a drive surface under the geometry. So that option is gone, but all the other stuff is there. So really don't have to worry about gouge check right now, especially since what we're doing is we're cutting on the left side of the cutter, working our way around the part. Clearance data, same as before. Same thing with roughing and more. We still have our roughing options right here and their machine controls and miscellaneous parameters. So that being said, we can do a save and calculate here. And I can already see I actually have my chain direction going the wrong way. So let me just go to my geometry and just do an edit real quick. And we'll just do a reverse. There we go. So now we're starting on the inside and basically kind of going around. If we go ahead and play this through in the Solid Verify, slide it down or slow it down a little bit. And that tool is basically kind of fanning through the points. So as it hits each one of those points, that tool is lining up exactly with that going all the way around. So for every one of these points, so from, get this part rotated right here. So from like this line right here to this line right here, it's doing a slow transition to follow that lines. And then same thing, kind of going all the way around. It's kind of lining itself up with all these different lines around here. And you guys can add these at a different angle to achieve a certain, maybe you want it to rotate over more on the one side versus the other side. And that's kind of what we're going to be doing in our next part here. But we can change the angles of these so it's kind of moving around. And that's more or less kind of for doing the trimming or doing like a chamfer around the outside of a part. Or after like maybe you've trimmed the part and then you go to trim, put a little a deburr operation on there or a chamfer kind of going around the outside edge. Okay, so that's kind of using it on the inside. Now if we do this with the outside as a trimming operation, we'll just go ahead and do another contour 5-axis. And we only have one option in here, so this box up here that you guys have been used to seeing where we can click this and it drops down, there's only one option in here. All right, so our drive curve. I grab this chain here, and I'll have to switch over to point to kind of skip over that gap there. And I'll go back to curve. Kind of work our way around here. And we'll go back to our point here. Oop. Spaceball got messed up here. And go back to our curve. Got to see what's going on here. Okay. There we go. So we got our chain around the outside. And since I already grabbed those outside lines once, I'm not going to make you guys painfully go through that again here. So I have all my lines right here. And if I just do a show, we have all the lines pointing all up and the going up. And like I said, I grabbed every single one. And if I want to, I could add even more in here, or I could kind of go less. All depends on, you know, what angle you want that cutter to kind of be at. So basically it's following the angle of these lines for that cutter going around. All right, and then we'll do our snap distance. Just put 1 inch in there to be safe. Grab our same tool number 2 here for going around the outside levels. Like I said, we're all good since we're kind of working on a flat part here and we're not doing a round one. Toolpath parameters, so that we can crank this up, make a nice tight tolerance. Sorting, chain on left. So this pretty, like again, it's a lot of the stuff in here, the default stuff is all good. So tool axis control, the only thing I'm going to change up is just going to go follow the ISO line direction again. And we should be good. So let me turn off this other toolpath. And you can kind of see we're coming in there and doing a pretty standard trim, just kind of going around the outside. So it's following, you can see that line there. It's following the curve around there. Now, one thing, I don't know if I've kind of mentioned this in the past. Well, I know I have, but if you guys don't like the color of this toolpath right here, and I'm not sure if everybody knows this, but if you guys go to your tool, and here's where that color is being pulled from. So maybe instead of orange, let's do a blue. Now we have a blue line. So if you guys don't like the colors of the toolpath in there, you guys, that's fully customizable for you guys. You can pick whatever color you guys want to see or represent it a little better. I know some of you guys have the blue background or a lighter color background, so the light colors are tough to see, so you can definitely change those up. But all right, let's go ahead and play this through. Coming around, tilting the tool, following those lines. Now, one thing I'm noticing here is I'm not going deep enough. I did go to the bottom of that curve, but if I kind of get in there, you'll see there's a little chamfer right there. And especially if we're doing a trimming on this, we need to go a little bit deeper on the trimming. So let's hop out of here for a second. And what we're going to do is, if we go to the tool axis control under advanced, I can put a minus 20 thou in there. And let me just kind of get zoomed in on this toolpath here, and we should be able to see this jump down. So now if I do a save and calculate, you'll see that my toolpath definitely jumped down for us. So going a lot deeper. Now, if you guys wanted to, we can also, if we want to do like a chamfer, and we'll actually be doing this on the next part, is if we go to our geometry, let's see, where is it at here? We can do an offset, and we can put like a negative number in there. So we're actually, technically we're gouging into the part, but we're kind of coming in there, and like I said, I'll show you on the next part, but we'll actually be doing a chamfer around the outside perimeter of a part. But any questions on these two operations right here before we hop over to another part? Nobody? All right. So let's close out of this one here, and we'll go to our next part. And tonight, unfortunately, I just have 2 parts for us, so. Wait for that to close down. And then I got 2 click happy. There you go. Okay, so here's kind of one where we're not so much doing a trimming, but doing a chamfer around. Now, the one really cool thing about this is, and this kind of got brought to my attention today with Ken, is so we can actually get these lines pointed at any direction. So we don't have to actually have these lines set up just to kind of follow the outside perimeter here, but if I have my lines kind of set up the outside perimeter, let me just kind of get a angle shot. You'll notice that I'm not going to be able to get a chamfer around the outside perimeter right on this edge. So what he did is kind of tip these up a little bit so it's at a different angle. So we're able to use kind of the side of the cutter and come around here and just do a light edge break going all the way around. Now, the real nice thing about using the contour 5-axis is if we kind of look like right here, we got a little bit of an angle there, but if we come over to this one, our angles go in the complete opposite direction. So you guys can have a lot of tool axis control with these lines. Now, like I said before, you guys can add as many lines in there as you want to really control it. But so we're going from, you know, one angle to another angle here, and what it's actually going to be doing is as it comes around and grabs this line right here, it's going to be, you know, parallel with this line, but then it's slowly going to morph into parallel with this line over here, and so on and so forth. So like I said, the more lines you have in here, the more you can draw, and you know, you can kind of swarf back and forth. That's the only really downfall of using the contour 5-axis is, you know, having to draw a couple of those lines in there if there's no geometry there. But the nice thing about it is, for this like particular one right here, we don't have a chamfer on this part. You'll see there, I don't have a surface to select right there going all the way around. So I mean, this is something I could not do, you know, very easily in simultaneous 5-axis because that drive surface is missing. Now, granted, we could draw it in there in SolidWorks and do all that, but it's much easier, simpler just to draw a quick line in there. And so what we actually did for this one is we can kind of see, let me kind of get a top down. You can kind of see what we did is created a midpoint right there and then drew a construction line that is parallel with the y-axis. And this is based off of your SolidWorks coordinate system, not your SolidCAM. And then what we can actually do is come in here and do a smart dimension and draw this line up here, and I can actually have these at different angles. So if I go over down here, and if we just do edit sketch real quick, you can see this one has a 15 degree over here. This one has a 20 degree. This one we're at 18 degree and a 20 degree. So these are all at different values, which makes the tool path, they're very flexible on what control that you guys have, and not so much based off of relying on, you know, locking out certain axes or relying off of the drive surfaces and the drive curves and all that stuff. So you guys get to pick your control using the contour 5-axis. So, and then also, if I haven't mentioned before, if any of you guys would like these parts, shoot me an email, and I have no problem sending you guys these parts when they're completed here, and you guys can play with them and kind of review them going through the video if you guys want to play them back. And same thing for the people that are watching on YouTube. And for everybody that is watching on YouTube, I do get a lot of comments on the YouTube portion of it. Don't read too much into those. If you guys do have a question or a comment, please send me an email on those, just because it's a little cumbersome to comment through the YouTube. So if you guys just email me directly, and for those of you guys that are live right now, you have my email address. But for those of you guys that are watching it on the recording right now, my email address is in the description. Here, I'll just quick show you because this kind of gets brought up. I'll just click on this one real quick. And if you guys come down to where it says show more, my email address is right here. So if you guys have questions, definitely shoot them over here. Try not to, you know, ask your questions in here. It's a little tough to get back and get you guys good response times on those. So if you guys do have questions, please feel free to email me or give us a call on support desk as always too. Okay, so let's go ahead and do our contour 5-axis here. And geometry. Oop, then I clicked it here. We'll go ahead and go all the way around. And I'm going to reverse that chain. So we're going the right direction here. And our orientation lines. So we'll grab that one. Now this green checkbox right here, If you guys do have a 3D connection space mouse, and I think it's not just the puck, I think you have to get the higher up model. You guys can actually program it so it hits that checkbox for you, so you guys don't have to, as you're rotating the stuff around. Okay, so we got our orientation line set up. We can just leave our snap distance pretty small part here. Don't really need a boundary. And let's go ahead and grab an end mill here. And this time we're actually using a ball end mill. One cool thing that it's going to do is it's going to take into factor that we are using a ball end mill, and it's going to move that end mill down so that ball is going past. So we're not working on the tip, we're working on kind of more the side of the cutter here. So kind of nice. Same thing, we're kind of working on a flat plane here. So we can just leave it in plane mode. Plane height is, inch above. One thing actually, Andrew, remind me, I want to show something that we kind of came across today in a profile operation for everybody. So Andrew, you got to remember that before we end the class.
You got it, man. I got it.
Okay, we got our tool number 1 right there. So we got our surface quality. I mean, we can leave it at, 8 thou. I just have tendency just to kick this over, but really don't need to. Same thing, sorting. We'll just do follow edge curve, tool axis control. We can kind of leave, everything kind of set where it is. And from right there, let's just do save and calculate. And let's just take a peek at kind of what's going on here. And so we're kind of coming in there, and I can already tell I need to get that tool down just a little bit deeper. So let's go ahead and we'll just put under our advanced right here, we can just put it's 50 thou, drop us in a little bit there. Actually, let's just go a little bit more. All right, let's save and calculate here. So you'll see we're, play this through here. Now the tool is going to slowly swarf over and pretty much align itself with that second line, kind of moving its way over to that third line that we picked. And swarfing over. So now we're basically cutting on sides right now. You can see that we're not really cutting any material. We're doing just a slight light deburr kind of going around. So let's take some meat off now. So like I was saying before, is we go to our toolpath parameters here, and let's just put a 15 thou negative offset in there. And now we should have a nice, basically chamfer going all the way around that inside of the part there. Let's go ahead and speed up a little bit here. So like I said, what we could have done is trim off, that inside surface there, and then if we want to do a chamfer around the outside edge, I mean, that's about as easy as it gets to throw a quick little chamfer on there without having to go through and modify the model or anything like that. Just a couple simple lines that we drew in there with a 3D sketch, and we have a beautiful part there. Let's just quick play it through. Let me switch this around real quick. I'm going to throw this on a 5-axis machine. And you can kind of see the machine rotating around. As soon as I can find the post that I'm looking for here. And there we go. All right. And one thing I need is, let's just get a distance, just a here, 4.6. Put that in my setup right here. Let's do 5 inches because I don't have a vise or anything like that in there. And I'm going to throw a holder on there so we can kind of see what's going on. Let's go to holder. And let's do simulate, machine sim. And now we'll be able to really tell kind of how that machine is moving around for us. All right, so let's slow this down a little bit. And it's telling me I'm crashing, but that's only because I'm actually gouging into the part, putting that chamfer on there. So you, like I was saying, you guys really have a lot of control of what's going on. Let me turn off the housing here, maybe get a side view of kind of what's going on. And one thing I did kind of forget to mention here is in our operation, under the tool axis control, if you guys don't have a 5-axis machine, we can definitely output this in a 4-axis too, but obviously that 5th axis wouldn't be moving, but you do have that same option like what we did with simultaneous 5-axis. So. And one thing I did forget to mention is we do have another celebrity star on with us, Ken Merritt, helping out, or just kind of viewing, seeing how things are going. And Ken, did I forget any great details since we got you in here? I might as well put you on the spot a little bit.
No, I think you did pretty good. I don't know if you could hear me. I said, no, I think you did pretty good.
And for those guys,
I liked it.
Ken, it may or may not, I know some of you guys kind of know my great work schedule, but I may or may not be here next week. So if I'm not here, Ken actually will be taking over the night class just for next week, helping out. So that way you guys can kind of keep going. And that will be converting HSM to simultaneous 5-axis. So, but kind of as long as we're on this part, you guys have any questions? It's been a little bit quiet tonight, but and if you guys do have questions, definitely feel free to shoot those out right now. I mean, we have Ken on the phone, and I mean, the guy that knows everything.
I was going to say, you're acting like you think I know something.
Okay, before I forget, the thing that I was going to show you guys, and this has absolutely nothing to do with 5-axis at all, but I kind of ran across this today with the customer. And it is, if we just do like a profile operation, one thing I kind of came across is this safety distance right here. Now, you guys will notice basically what the customer was asking is he wanted to change up this value right here. Now, there is actually no place to actually put that in for the settings. If we go to your SolidCAM settings, we have under the coordinate system, as soon as I can find it here, we do have start, clearance delta, and Z level, but we don't have our safety in here. One way of changing things around is we can do it from, instead of doing part clearance level, we can do operation start level, but it was brought to my attention this may affect some post processors that are out there. So dug a little deeper in there and try to figure out where that number is being pulled. That number is actually being pulled from your guys' VMID file. And that's under the working style. So right here, this safety distance is where that number is being pulled from. So if you guys do or want to change around that number, so it comes in as a default number of, on my other computer was actually coming in as 78,000, some oddball number. You guys do have full control over that in your VMID file of what that default number is. So like I said, completely nothing related to 5-axis at all, but it did kind of come to my attention today, and definitely want to share this with you guys as a quick little tip trick kind of in there. But all right, guys, any questions at all?
Hey, let me throw something.
Yeah.
Let me throw something in on that safety distance. If you are unaware of how to change that, just call us, and our tech guys, our post team, can make that change for you and send it back to you.
Oh, absolutely, guys. Yeah. If you guys, I kind of look at the post processor as a registry. For those of you guys that don't know what the registry is, if we go to in here, if you guys make just one wrong move in here, we can scramble so much stuff in your computer. That's kind of the way I look at it with post processor. There's a lot going on in there. That's what we're here for. We got a great post team, great support team. Give us a call or shoot me an email or shoot your post guy email, and we can definitely get that fixed up for you guys. So definitely, if you guys aren't feeling comfortable with that, that is what we're here for you guys. So, and thanks for pointing that out again. But all right, guys, anything else? Any questions, concerns? Anything else you guys wanted to see? Did everybody fall asleep on us? All right, guys. Well, I guess if we don't have any questions, that's about all I can think of for Contour 5-axis. Unless I'm, Ken, is there anything else that you can think of for Contour 5-axis?
The only thing you might want to go through is we could take just a few minutes and talk about how we created those lines. That might be kind of interesting to some people that maybe have never done that. You know, the constraints and the way we balanced all that. Yeah,
absolutely. So let me just kind of go through and just hide what we previously did here. And where's that line pulling from? Oh. Okay, so kind of starting off from scratch right here. Basically, all we did is added a couple lines in here. So if we
just do one corner. Yeah. One corner would be enough to take care of it.
So I'll just do a center line right here. And I need to do a 3D sketch. Grab that center line here. And so what we can do is, I can't grab a midpoint on here. There is no midpoint available.
And that's because it's a spline.
Yep, sorry. Yep, it is a spline, so we have no information at all. So what I'm going to do is just draw a simple line to just a general midpoint right there, and then I'll draw another line. So we just have two lines right now. So what I can do is grab both of these lines, and by making these equal, they're going to kind of self-align and find the exact midpoint for us. So now what we can do is, now that we have a midpoint in there, is we can do a regular line going straight up. And if I grab this line right here, I want this line to be right with my y-axis, pointing straight up. So if I kind of get the bearing straight here, you'll see that that line is pointing straight up for us. And actually what I can do for this line also is I can just say for construction. So now what we can do is do another line and have that angle kind of going out. So now I can come in here, do a quick smart dimension, and let's say I wanted it at 20 degrees, and there we go. So it's pretty much easy as that. And this is a pretty, if you guys are running the splines, that's where the biggest issues kind of come into factor, is not being able to snap a midpoint or anything like that. So that's where these two lines really come, into helping out here, is just kind of find the midpoint based off of, this line is exactly equal to this line. It's going to bounce right to the middle. And then we're able to grab that straight line kind of coming up and going out. So
one other thing I would say, and I should have mentioned this earlier, do the two equals over on the opposite corner to get that midpoint.
Okay.
And then we'll show them how to line that up so it's truly aligned towards the center of that arc.
Yeah.
Or the center of that curve, I should say.
So grab.
One of the things you have to do here, the reason that line is still blue is because we haven't constrained it on the other angular function. So once he makes these two lines equal, then that midpoint would be right towards the center of that arc or that curve. Now, if you create a plane, I wouldn't even go that far. You don't even need to do that. We can do a plane off the vertical line, and that point should give you a full plane.
I'll just, since I have it in there, just do a long Y here. Okay.
Sure, that'll work too. Either way, and then just do a reference geometry and throw a plane in there. And this gives us a real quick, easy way of kind of lining the geometry up in a way that allows us to manage that other piece of geometry. Notice how it's out of plane right now, and we put that angle on it, and so we want to take this and now bring that into alignment. Now, one of the things that you would want to do, you're not going to be able to do it in this case because of the order that we did that in. What I would normally do with this is the construction lines that we built, I would do in one 3D sketch, and the lines I'm going to use for tilting, I would do in a second 3D sketch after I built the plane. And that way I can give them an on-plane constraint and pull it in there. So it's not only at the angle off of the vertical line, it's also held within that plane between the two corners. So I think that's, and again, if you guys need help with that, just give us a call. We'll help you out with that.
Yeah, absolutely. And what Ken's saying is, so you can kind of see this line is kicked over at an angle. This line would be right in line with the plane. Is that right, Ken?
Yes. Okay. Yes. And it's just an order of events. Remember, SolidWorks is essentially a chronologically based modeler. So because we put the plane in after the sketch, and the sketch contains both of those entities, we wouldn't be able to align that line into the plane because the plane doesn't exist at the time that line is there, if that makes any sense. So time-based modeling can be a little tricky, but if you know the rules, the do's and the don'ts, it's pretty easy.
Got to think ahead a little bit.
Absolutely. That's about the only thing I could think of.
Perfect.
Be interesting.
Any questions on that, guys? And like Ken said, if you guys do have questions with that, definitely give us a call. Let us know what we can do to help you guys out. And, I've said this before, and, I'll say it again. SolidCAM wants to be the absolute best support system that we can give you guys, hands down. So we'll do whatever it takes to get you guys up and going. Like I said, that's kind of why we started doing, a bunch of these. Let me get over to the channel here. A bunch of these, helpful videos, doing the night classes, any free training that we can provide for you guys. Let us know what we can do to help out. We do have what's called the SolidCAM program now. I have to get a little bit more details on it, but pretty much that you are going to be hand-holded through your entire SolidCAM experience. So, like I said, whatever the case is, you let us know what we can do to help you guys out. Just for instance, this right angle head, customer had a question about it, would like to see a video on it. So the next day we actually added that in there for you guys. So like I said, let us know what we can do to help you guys out on, post-processor to toolpath to even your SolidWorks to, recommended computers. I know I've kind of gone through this in the past, but we have a great spot where, you can kind of come in and check out. This gets updated every few months here on, what's a good computer to buy for my company and all that stuff and, requirements. But, we're all well-versed in the CAM, but also well-versed in computers and programming and machining and tooling and all that good stuff and fixturing. So let us know what we can do to help you guys out and make the life a lot easier for you guys. So.
And we also have a brand spanking new partnership with SolidBox.
Yeah, why don't you tell us about that?
They make some pretty sweet computers. We just started a partnership here just in this last week with a company called SolidBox, and their mainstay is that they create very high performance versions of Dell desktops and laptops. They use Dell because they get a much better quality control on them and much better performance out of the systems as well. So as you scroll down through their page here, they do some real hot rockets. I mean, they've done some stuff. They actually have their own OEM relationship with both Dell and with Microsoft, and they'll take a Dell, one of the Dell versions, and instead of just leaving it with that, sometimes they'll replace hardware that's in it with higher performance hardware, and they'll actually load their own custom version of the Windows operating system on it, which they've stripped out all of the bloatware and improved the performance of the operating system. So it's pretty cool the way they do it, and they go with the highest grade memory that they can get a hold of, and then they use the best motherboards and such for that. And so they're very, very fast computers compared to the same model just purchased from Dell.
And the best part about it is when you guys have an issue with your computer, for those of you guys that, I mean, not slamming Dell or HP or any other computers out there, but the support side of things has always been very tough. These guys are on their game. You guys get somebody that English is a big one for me, and that actually pick up the phone right away, so which is really nice. And Ken, if one of our guys were interested, how would they go about? Would they contact you for getting hooked up?
Well, the easiest way would be just to go directly to SolidBox and let them know that you spoke to Ken Merritt or Kevin Rankel at SolidCAM and that they recommended that you give them a call, and they'll know that you've been referred to them through us. They also have a service that they call a refresh service, where you can actually send them your existing computer and they'll go through it and tune it up. Now, that's not available for all computers. They have some age limits on the computers, and they also have some hardware restrictions. They're not going to charge you for doing a tune-up on something that isn't tunable, if that makes any sense. But it's definitely worth talking to them about and finding out, give them the details on your computer, and they can tell you what they can do for it. Now, if you're interested in spending a little bit of money and enhancing some of the hardware that's in your computer, quite often that can be a very affordable way to boost a computer up to the next level as well.
Yeah, and the nice thing is these laptops or desktops that you guys get from them is 100% ready to go out of the box for your SolidWorks and SolidCAM. So there's no having to tune anything or anything like that.
Yeah, they can even install the SolidWorks and SolidCAM for you and make sure that it's installed in such a way that you don't have to worry about anything. It's ready to roll.
Perfect. So that's some of the new stuff that's coming up, guys. And like I said, we're always changing up stuff and trying to help out and do whatever we can for you guys. But just another channel. And like I said, CAM software, normally doesn't care about, what you're running for a laptop and all that stuff. But like I said, going the extra mile and trying to get you guys a workstation or a laptop that's going to work the absolute best for you guys. So perfect. Well, if we don't, and Carlos, thank you for the great comment there. Appreciate that. If there's no other questions or concerns, we'll kind of end it here. And like I said before, if you guys do have something does pop up afterwards, after you maybe watch the YouTube video, you do have questions, send those over to me in email, kevin.rankel@solidcam.com, and get to your guys' questions right away. And with that being said, next week we'll be doing the converting HSM to a simultaneous 5-axis. So pretty cool stuff that they've done right there. And we'll see on who's teaching the class. But all right, guys, have a wonderful night. Thanks again for taking your time out of your Tuesday night to attend these classes. I really do appreciate it. And one last thing is, if you love the software, tell your buddies down the street. If you get them into a demo, you get $100, or the company gets $100 Visa gift card. And if they purchase the software, it's 20% of that sale. So really cool program. And I actually did a video of one of our customers that took advantage of that and sent his whole trip, or his whole family, on a trip to Jamaica with helping his buddy out by telling him about SolidCAM. So pretty cool program. But I guess so with that being said, guys, have a wonderful night, and we will see you guys next week. All right, see you guys.
Thanks, Kevin.
Thank you.